All right, boys and girls, ladies and gentlemen, chaps and their ladies, let's continue in our saga in developing an interest and a curiosity and understanding in conic sections. We're doing section 9-3, part 2. Okay, the first thing we're going to learn how to do is we're going to learn how to graph a conic section on our calculator. Whenever we have a y-squared, which is in the majority of conic sections, you're actually going to get two functions that you're going to have to enter. And as you know, your calculator only knows how to enter a function. So if you have a conic section, such as a circle, which is not a function because it doesn't pass the vertical line test, you're going to have to break it down into two pieces. Okay, the top half and the bottom half. The only time you will only need to enter one function for a conic section is if you have a vert parabola, because as you can see that is a function. Okay, even a zont parabola is going to have two pieces, the top half here in red and the bottom half here in blue, which we're going to get two different functions for. So let me just erase that real quick. And then we will talk about how to graph a conic section. How you graph a conic section is you solve for y and then plug them into your y equals on your graphing calc. So to solve this equation for y, I'm going to get y by itself, so I'm going to subtract the 12x squared on both sides. So I get 6y squared is equal to 48 minus 12x squared. I'm going to divide by 6, divide by 6, divide by 6. So we now have y squared is equal to 8 minus 2x squared. I'm going to take the square root of both sides, switch colors so you can see. And of course, when we take the square root of y squared, we get y is equal to, now don't forget, we have a plus or minus, and there are our two functions. The square root of 8 minus 2x squared. So you're going to punch into y1 on your graphing calc, square root of 8 minus 2x squared. You don't need to simplify it. You can, but you don't need to. And in y2, we're going to punch in negative radical 8 minus 2x squared. Okay? Go ahead and do that in your graphing calc right now. Go ahead and try it. Hit the graph button. Let's do a zoom 6. Let's do a zoom 6 so we all got the same picture. And are you there? Stop the tape if you need to, but I'm going to reveal the image. Okay? Your image should look like that. We can see that sure enough that is an ellipse that is centered at the origin, and it has a top half and a bottom half. Alright, and that's in the zoom 6 mode. We can also do a zoom square mode, and it's going to look more like more like a circle. It would be a little bit more stretched out. Alright, let's go on to the next. Okay, we can see right now that this once again is an ellipse, because I know it's an x squared plus a y squared. Okay, it's not quite in HK form right now. Pretty close to it, but not quite. Alright. We're going to solve this for y, though. So what I'm going to do is I'm going to, again, subtract. I'll do this one in blue. The x squared term, so minus x minus 1 squared minus x minus 1 squared. So I have 9 y minus 4 squared is equal to 72 minus x minus 1 squared. Divide by 9. Okay, so it looks like I have y minus 4 squared is equal to 8 minus x minus 1 squared over 9. I'm now going to take the square root of both sides. So switch colors, square root, y minus 4 is equal to plus or minus square root of 8 minus, in parentheses, x minus 1 squared over 9. Make sure you're pressing the right buttons. You've got to group these correctly. Okay, so there is your function. Not quite done to solve for y. I'm going to add 4 to both sides. So plus 4. And this plus 4 is outside the rad. So your equation, you're going to type into y1 is going to be y1 is equal to, I'm going to write this so I can not get that little thing up top there, is equal to radical 8 minus x minus 1 squared over 9, outside the radical now, plus 4. And y2 is going to equal radical 8 minus x minus 1 squared over 9, outside the radical, plus 4. Go ahead, type that into your calc. Let's see what happens. Type it in, type it in, type it in, and a picture that looks something like that. You can see now we have two functions. We have the top half right here. We have the bottom half right here in blue. That's why you had to type in two different functions. All right. This one's a little bit different. We're going to actually have to complete the square in order to solve this for y. But just looking right here, I'm hoping you guys can see that this is going to be a circle of some sort. You'll see why in a minute. Okay, but in order to solve this for y, I'm going to get the y terms by itself. So I'm going to subtract the x squared. I'm going to subtract the 5 from both sides. So it looks like I'm going to have y squared plus 6y plus blank. Ooh, yeah, we're going to complete this. The square is equal to negative x squared minus 5 plus blank. I'm going to complete the square now. Half of 6, take my b term, cut it in half, so I get 3. Square that 3, I get 9. I'm going to add 9 to both sides. So I have y squared plus 6y plus 9. That, of course, becomes y plus 3 quantity squared is equal to negative x squared minus 5 plus 9 is plus 4. I'm now going to take the square root of both sides. Whoop, whoop. So it looks like y plus 3 is equal to plus or minus square root of negative x squared plus quattro. I'm going to subtract the 3 from both sides. So y is equal to plus or minus the square root of negative x squared plus 4 outside the radical minus 3. Go ahead and graph those on your graphing calc. Put them in two different functions, in y1 and y2, the positive one, the negative the other. See what you get. You should get a circle. This time I actually did a zoom square on your calculator. So not only did I do a zoom 6, I followed that by the zoom square, so I get my circle that looks like a circle. If you don't do the zoom square, your circle is going to look more elliptical, because it's going to be a little bit stretched out on the horizontal due to the rectangular shape of our 10 by 10 grid. All right, general form of a conic. Okay, we've done the HK forms, or the standard forms, all along here. The general form of a conic could have up to 6 terms. The ax squared term, the y squared term, the c term, the regular x, the regular y, and then of course we could also have a constant term too, and all that is equal to 0. If you do not have a bxy term, if you don't have an xy term, then it's just a regular straightforward conic. If b is not 0, in other words, if there is an xy term, then your conic is rotated. And our level 2 kids, we won't worry about that. The level 1 kids, we are going to be dealing with some rotated conics too. Okay, so whenever we see the xy term, we know that we have a rotated conic. All right, we did some problems in class the other day, or maybe today, or maybe tomorrow, depending on when you watch this video. But we did some problems in class where you were recognizing non-rotated conics just from the standard form of the general form of the equation. If you understood that and you're in my level 2 class, and so we're not worried about the rotated conics, you can probably skip this next little section of the video. To recognize a conic that's rotated just by the equation in the honors group, now we need to actually use the discriminant of the conics, which is b squared minus 4ac, to recognize what type of conic we have just from our equation. So if b squared minus 4ac is equal to 0, we have a parabola. If b squared minus 4ac is negative, we have an ellipse or circle. And if b squared minus 4ac is pos, then we have a hyperbola. So let's try some. Okay, identify the type of conic. In this case, our a is equal, I do need a marker. A is equal to 1. B is equal to 0, so actually we can do this without using the discriminant, but we'll try so anyway. And C is equal to -3. Just looking at this conic right now, we see we have a positive x squared and a negative y squared, so this is going to be a hyperbola, doing what we did in class, but let's use the discriminant to verify that right now. We're going to do b squared minus 4ac. If this turns out to equal 0, we know we have a parabola. If this turns out to be positive, we have a hyperbola. And if this turns out to be negative, we're going to have an ellipse or a circle. So let's figure out what happens here. B squared is equal to 0 minus 4 times A was 1 times C is -3. 4 times 1 times -3 is -12. So I have -12, which of course is positive 12. It's a positive number, so we have a hyperbola. Let's try on. This time we do have a rotated conic, so you can't tell just by looking. We need to use our discriminant. B squared minus 4ac. Again, if this equals 0, we have a parabola. If this is a negative, we have a circle or ellipse. And if this is positive, we're going to have a hyperbola. Okay, so let's plug in the values right now. B is -1, so -1 squared is 1 minus 4 times A is 1. C is 3. It looks like I have 1 minus 12, which of course is equal to -11. So this is either a circle or an ellipse, and probably an ellipse, seeing that we have a 3 and we have a 1. Okay. One more here, identify the type of conic. We do have a rotated conic right here, so we can't tell just by looking. So we're going to do b squared minus 4ac. Okay, b is 4, so that's 16. A is 2. C is 5. So it looks like I have 16 minus, I'm doing the math, 40, which of course is -24. I have a circle or an ellipse. Jump on my elliptical. Just kidding. All right. To graph a rotated conic on the calc, and again, this is only for the level 1 kids. Put the equation in quadratic form in terms of y. Use the quadratic formula to solve for y. And again, we did this in class, and this is just for you to watch and get a couple more examples of. Okay, the first thing I'm going to do is I'm going to list my terms in descending order of y so that it'll be in quadratic form. So I'm going to have 3y squared minus xy plus x squared minus 5 is equal to 0. So now, looking at my quadratic formula, or the quadratic form of y in terms of y, the y squared term is my a term, so a is equal to 3. My y term is -xy, so b is equal to -x. And c, my non-y terms, is x squared minus 5. So we're going to throw those into our quadratic equation, our quadratic formula. So I'm going to have negative b, so that's, let me switch colors, neg x, so that's positive x, so I'm going to write this out, neg x plus or minus square root of neg x of b squared, which is neg x squared, minus 4 times a, which is 3, times c, which is x squared minus 5, all over 2a. So there is our two equations we're going to punch into our calc. We can simp this as much as we want. We probably would want to a little bit. And 2a was 2 times 3. So neg x, let me switch colors here. Neg x is going to be x plus or minus square root of neg x squared, which is x squared, minus 4 times 3, which is 12, times x squared minus 5. And we could distribute that 12, but we don't need to. Just kind of keep that like that. Keep things easy. All of that is over 6. Punch both of those equations into our calc. We see we have two equations. These are both y equals. Okay, so y equals x plus the radical all over 6, and y2, we're going to punch in y equals x minus the radical all over 6. Go ahead and punch those in. I'll do a crossword puzzle while I'm waiting for you. Maybe I'll do one. And you should get a picture that looks something like that. And there is our rotated ellipse. And you can see a slight rotation going this way. Okay, let's try one more. Okay, let's do one more here. Let's first of all put this in descending order of y's in order to put this in quadratic form in terms of y. So it looks like I'm going to have 5y squared plus 4xy minus 4y plus 2x squared. Still looking, plus 3x minus 20. So now, here's the fun part. Y squared is our only y squared term, so a is equal to 5. Our b term is the y terms. I have 2 of them. If I factor out the y, I basically have y times 4x minus 4, which means b is equal to 4x minus 4. And c is going to be all my non-y terms. And this, of course, equals 0. All of my non-y terms, so c is equal to 2x squared plus 3x minus 20. I'm going to put these into the quadratic formula. So y is equal to negative b, so that's negative 4x minus 4 plus or minus the square root of b squared, which is 4x minus 4 squared, minus 4 times a times c, and of course c is this whole thing right here. It's going to go right there. Okay, we can simp this as much as we want, but again, I would, and all this, of course, is over 2a, which is 10. So I don't know how much I would simp this much more than what it is right here, okay? But I can write it, So here's our equation. So I'm going to get something that looks like y is equal to, I'm not going to simp that, negative 4x minus 4 plus or minus, so I'm going to have 2 of them, radical 4x minus 4 squared. Why would I FOIL that out? Minus, the only thing I'm going to do is just multiply the 4 and the 5, 20 times 2x squared plus 3x minus 20 close my parentheses, and all that is over 10, and I don't have room to write that, but there is your equation. Go ahead and punch it into your calc. Punch it into your calc. I'm doing my crossword. All right, welcome back, Level 2 kids. Here we go. We're going to solve some conic systems, and as you know, we can solve a system a whole bunch of different ways. We can do it graphically. We can do it algebraically. We can use matrices, as you know, we did in Chapter 7. But right now, I'm going to just make a rough sketch graphically so you can kind of see what's going on. The first equation here in red that you know is a circle with a radius of 3 centered at the origin. This guy right here in purple, that's a right-facing parabola. It actually got shifted a little bit to the right 3, and I actually know the answer, so it has this point right here, and it goes right. So I have only one answer. You remember from what we did in class, a conic system could have up to 4 answers. It could have 0 to 4, like for example, our parabola could have been right here and missed the circle, or it could have been, the circle could have been inside the parabola if it went around like this, right? It could have been up here, it could have just missed, right? I could have one answer, like right here, where I just have one, where the vertex is on the circle, or I could have gone like this and just had one answer, right? I could have had 2 answers if my parabola did something like this. I could have had up to 3 answers if my parabola did something where it then went through and hit 3 times, or I could have 4 where my parabola hits 4 times. Okay, but we're going to solve this now by substitution because it's easy to see now that I can replace my y squared in the top equation with x minus 3. So I'm going to have x squared plus y squared, which of course is x minus 3, and that's equal to 9. I now have a quadratic equation in terms of x. I'm going to subtract 9 from both sides. X squared plus x minus 12 is equal to 0. To solve this for x, we're going to factor x minus 4, x plus 4, whoops, slow down there, Corbett. X minus 3 is equal to 0, so therefore x equals neg 4, or x equals pos 3. We're not quite done. We need to take these answers, okay, these answers here, and plug them back into one of my equations for x. This, in order to solve for y, it would probably be easier to plug them into this second equation because it's just a little bit simpler. So I'm going to take my x equals neg 4 and plug it back in up top there. I'm going to get negative 4 minus 3 is equal to y squared. So y squared is equal to neg 7. Well, we know that y squared is never equal to neg 7. That has imaginary answers, so this answer doesn't work. If x equals 3, I have 3 minus 3 is equal to y squared, which means 0 is equal to y squared, which means if x is 3, y is 0, and the only ordered pair I had was 3, 0. Okay, looking at this guy right here, it looks like I have an ellipse up top. This is actually going to be a Zot ellipse, if I am thinking about that correctly. Centered somewhere, I'm not quite sure where. Down at the bottom, I'm going to have a circle. Okay, I'm going to have a circle. Let me switch colors. Again, not quite sure what my circle is going to look like, but it's going to look something like that. So I could have either 2 answers as I drew. If my circle were bigger, I could have up to 4 answers. If my circle were smaller, I could have no answers. It's also possible that my circle could intersect the ellipse 3 times. So let's figure out what's going on here. I'm going to solve this by elimination. I'm going to get rid of my x squareds. And I'm going to do that by multiplying my bottom equation by neg 4. So I'm going to multiply that by neg 4, and I'm going to write that up top now. I'm going to get neg 4x squared minus 4y squared plus 4 times 27 is 108 is equal to 0. I'm now going to combine these two equations up top here, right up here. I'm going to combine these two equations. The x squareds will go away. I got 9y squared minus 4y squared, which is 5y squared, minus 36y, plus 108, 180. Let me erase that. Plus 108 is equal to 0. Okay, I'm just looking at this equation right now and y. I'm trying to factor in my head right now to figure out what y might be, but since it's so hard to factor that, I'm just going to write to the quadratic equation. And you'll also see y in a moment. Okay, but I now know that y is equal to negative b, which is neg 36, which is 36, plus or minus the square root of 36 squared minus 4 times a times c, all over 2a, which is 2 times 5. So y is equal to, let's do the bottom first because that's easy, 36 plus or minus, well, 36 squared is 216. I'm sorry, it's 1296. I knew that didn't sound right. 1296 minus 4 times 5 is 20. 20 times 108 is 2160. So we have a negative number inside the radical, so there's no real answer for y. So therefore, there's no solution to our system because y has no real answer, which means now if we think about what was going on, okay, in our system, I can probably draw another little graph down here. Our circle, I believe, was too little to fit inside, fit too much inside our hyperbola, our ellipse. Okay, last one. In fact, you guys can do this one on your own. Why don't you stop the tape and you're going to solve this. It looks like we have an ellipse and we have a line, so we could have up to 2 answers here, 0, 1, or 2. Go ahead and solve this algebraically, and I'll be back in a moment with your answer. No, even better, first 10 people to email me a correct answer for the solution to this system will earn a bonus point on our next test or quiz. That's it, folks. We'll see you soon. Have a great day. Adios.